Cool. Hi there and welcome. So appreciate you staying, especially getting on to Friday afternoon. So thanks for listening to, or coming to listen to me drone on about building images. So we're going to be talking about how to customize images for Windows and Linux using the Azure Image Builder and the shared image gallery. Who here has heard of the Azure Image Builder? Cool. How many people have actually used it? Cool. So I'm going to be talking about those items today and how that pairs with the shared image gallery. So we're going to look at image creation and management. We're going to talk about some scenarios, so how you can use these services to create your corporate golden image and then distribute it. We'll then move on to building on top of that golden image and testing it. And then lastly, we'll finish up with automating and enhancing the process. So when we think about customizing images, there's a couple of ways we can do it. One way we can do it is to take an Azure Marketplace image. We take a vanilla OS. We create the VM using that vanilla OS, and then we do some customizations when that VM actually is created. We call those post-provisioning customizations. Now, they have their place, but if your post-provisioning customization takes 30 minutes to run or 40 minutes to run, you're waiting all that time before your VM is actually useful and can take on a workload. So in terms of performance, that's not particularly performant. We see customers creating custom images because they want all their applications baked into the image, and then that way when it boots, they can literally have the VM up and ready to take on the workload. An example of that would be in a scale set where you want to scale up and keep adding VMs. We also see customers building images for compliant reasons. It could be that they always have to, or their security and compliance team mandate that the image must be set up in a certain way. It must be hardened and have all their agents in. And anything that gets built inside the corporation must always be built from the corporate golden image. And then lastly, we see customers building customized images for licensing reasons. It could be that Azure Marketplace doesn't supply images that have the licenses you want, and you want to port over your on-premise licenses and therefore have to build a custom image. There's also the pain of building custom images. One of the things we actually saw from customers and their feedback was, look, can you make it easy to build custom images for me? When I have to build custom images, I'm having to think about the underlying tooling. I have to go and learn new tools, or I have to go and write scripts. I don't really want to be in that business. I don't want to learn the differences between the different cloud platforms. We see a lot of customers building custom images for the other cloud vendors, and then they have to build them for us, and it's just another thing for them to learn. Also, there's differences between different major and minor operating systems as well, and you have to take that all into account. And if you're pretty serious about building images, then you need to build some sort of automation pipeline and management system. So taking that all into account, we actually went away and we produced the Azure Image Builder service. And quite simply, with the Azure Image Builder service, you can describe a custom image in a template, submit it to the service, and it will then go away and build it for you. You don't need to know about the underlying tooling, how it happens. It just does happen, and you get an image at the end of it with all your customizations baked in. And we'll talk a bit more detail. The image builder also can be integrated with the Azure Shared Image Gallery. This is an image management system, and I'm going to talk about that in a bit more detail. So let's talk about the image builder. So the image builder, who here was at my session last year? Anybody here last year at my session? Okay, 1 or 2 people. So last year, we actually announced private preview for Image Builder. Slightly embarrassing. I was presenting here at Ignite, and we could only support Windows. So it wasn't a particularly unified experience. We actually now support Windows as well as Linux. We were Linux first, and so when I say we support Windows Server and Windows Client. It's very simple. As I mentioned, you just have to describe your image customization in a template. You can build compliant images. You can just literally bring your existing scripts and migrate them from on-premise. Integrating Image Builder with the shared image gallery allows you to have this whole management image creation and management system. There's also integration with Azure Devops, so you can automate creating images with Azure Image Builder and the shared image gallery. And lastly, we also support Azure Stack. So if you're building images for Azure Public and Azure Stack within the same pipeline, you can get Image Builder to create the image for Azure Stack as well. So the shared image gallery, who here has used the shared image gallery? Okay, it is a very cool service. What it allows you to do, it allows you to create an image gallery inside your subscription. And inside the gallery, you have these image definitions. Essentially, these describe images that are basically of a very similar description. So you could call your image definition my prod images or my golden images, my Ubuntu images, whatever you want. And then inside the image definition, you have multiple image versions, or you could even have one, but you have image versions. And it's actually the image version that is the image. So when you actually inject an image into the shared image gallery, you just increment up the version number. Now, the beauty is with this is that with the shared image gallery, for an image version, you can actually go away and replicate it to any public region in Azure with a single API call. So you don't need to do any blob copies. You just do an API call and say, right, I want to get this image version and I want it replicated to my production regions, and it just gets handled in the background. You don't have to worry about anything else that goes on underneath it. Also, you can scale an image version. So let's say you're deploying hundreds of VMs all at the same time, and you need a bit more throughput. You can increase the number of underlying replicas in a region for a particular image version, so you have more throughput. It's also highly available. Shared image gallery supports zone redundancy as well within our data centers. And then lastly, this is quite a cool one. It actually supports sharing images. So if I created an image and I wanted to share it with any of you in the audience, I could easily do that. I can share it across Azure Active Directory, across tenants, and across Azure subscriptions as well. So that's pretty cool. So let's talk about the Azure VM Image Builder itself. What's it actually made up of? It's made up of three core components. We have the source, the customize, and the distributes. So source, we actually support ingesting Azure Marketplace images, both Windows and Linux. There's a list of the ones that we support. In actual fact, the Image Builder will allow you to ingest any vanilla Marketplace OS. It won't restrict you, but when I say we support, that means we test with it. We also support ingesting existing custom images. So if you've already got custom images that are managed images, or you're using a shared image gallery already, Image Builder can consume them too. Customize. Image Builder can apply a certain amount of customizations. You can bring your existing shell scripts, PowerShell scripts, inline commands. Image Builder will run those for you. You can also copy files into the image as well. We provide functionality for that. And lastly, we provide Windows restart functionality for those apps that require restarts in between installation. Lastly, we have the distribute. So Image Builder allows you to distribute to multiple targets within the same build. We can distribute to VHD, so if you want to offload it onto Azure Stack, that's the distribution you need. We also support distributing to managed image and the shared image gallery. So how does this all work? What do you actually need to do? First of all, you actually need to curate a template. And don't worry about this sort of trying to squeeze your eyes and see this template. You're going to be sick of seeing templates at the end of this session. We're going to dive into them in a lot more detail. But essentially, the template is made up of some properties. And you have your source, which is obviously similar to what you just saw on the high-level diagram. And that describes what the source is going to be. Managed image, it could be publisher off a SKU, it could be a shared image gallery. And then you have the customize. The customize section is an array. You can have multiple customizations in there. And then lastly, we have the distribute portion of it. And this is an array as well. You can have multiple distribution points. Now, what happens is, once you've constructed your template, you submit it to the Image Builder service. At that time, it does its syntactical checking, and then it will download any associated artifacts that are referenced inside that template. So, for example, if you're referencing a script, it will download them. And where it actually downloads them, when you submit the template, it creates a staging resource group, and it will be prefixed IT_. Inside there, it will create a storage account, and that's where it will store the files for that particular template. You'll get an acknowledgement back that that was successful, and then you invoke run on that particular image, that image template. So in the background, or what you'll see an image template artifact, and then you just invoke run on that. So let's jump into some demos. Let's have a look and see what we've got. Cool. So what we have is we have a GitHub repository that this has a lot of samples on it for you. Every time the Image Builder team releases a new feature, I create a quick start for it and it gets tested. We also have a bunch of solutions as well for you to try out. So if we go into quick starts, we can just see here. And you can see I'm creating custom images for Windows and Linux. One's for the managed images, one's for shared image gallery, and so on, how to create them to VHD. So the idea of these is to literally get you going pretty quickly. If we jump into a Linux one, and the reason I'm going to go have a look at a Linux one first is because we're going to be doing a bit more on Windows after this, is the way these are designed, you literally can just copy and paste through these, so you have to do some setup, and you can copy and paste this code. All you need to do is actually just paste your subscription ID in, and that will go and create the image for you. Let's have a look at what the template looks like. So first things you can see is that we have you have a type, virtual machine images. Image Builder is its own first-party service in Azure and has its own first-party resource provider. You'll see the properties. We have a build timeout, so you can tell Image Builder how long you expect it to take. By default, it's 4 hours if you don't put anything there, and it'll go up to 16 hours. Here you can see the source. It's publisher off a SKU, the same way you create a VM. And then here in Customize, you can see that I'm going to be running a shell script. And this links straight to my GitHub repo. What will happen is Image Builder will download it, and it will just go ahead and run it. I also have a file customizer as well. And this file customizer is going to go back out to that GitHub repo, download this file here, and then it will place it into this location down here. And then lastly, we have another shell customizer, but doing things slightly differently here. We're just running some inline commands. So pretty simple stuff. And then lastly, you have this distribute. And here we're actually selecting that we want it to be the shared image gallery. And then you just specify the image definition that it's actually going to be passed into. And so that's roughly it, as well as some of the replication regions. So what I wanted to do was just literally just give you an overview of where the documentation actually resides. So you can go away and play around with this yourself. The demos I'm actually going to show you straight after this, all of them are documented. You can actually go and try them out yourselves, and everything I do, I test. So that's that one. So let's just go back to the slide deck. So what I'm going to show you is how you can actually create your first image using Image Builder, and this is going to be a golden image. So what are we actually going to do? So first of all, we're going to have some configuration as code. This is going to be the Image Builder template, and this has got obviously the properties, and we're going to have a look at what those properties are. And just to make this example a bit more interesting, what I'm actually going to get Image Builder to do is go and download the script and an executable from Azure Storage. But I'm going to get it to actually download it from a private container. So it's not publicly accessible. Image Builder needs to actually go and authenticate with Azure Storage. And the way it's going to do this, I'm going to give Image Builder a user identity that has access to that private container. We'll give Image Builder the configuration, and then when it finishes, I want it to distribute to an Azure Shared Image Gallery image definition. In this case, I want to send it to the Win Server images. So let's jump back to the laptop. Okay, so let's go to my jump box. Okay, so here's my jump box. So I'm not going to go through all the code that you saw in the quick start, so I'm just going to pull out the salient points and things you should be aware of. All the code you see here, this is written in PowerShell, but we have plenty of AZ CLI and Bash in the repo. So here, what I'm doing is, first of all, I'm going to create a shared image gallery. This has already been created, but I just wanted to call out a common mistake we see is that customers think that Image Builder will go and create the shared image gallery for them. It doesn't. The shared image gallery must exist before it actually, Image Builder actually runs. It will return an error during validation. And then what you need to do is you actually need to give the Image Builder service principal rights to go and inject the image into the image resource group. So once you've created your shared image gallery in a resource group, you then must give Image Builder contributor rights to it. If you're doing a customization and you're building on top of an existing custom image, Image Builder must have reader rights on the resource group where that image resides that you're trying to build on top of. What I've done is next, I've created a managed identity. This here is just basically giving me back an identity. And then what I do is I take that identity and I go and update the template. So let's have a look at what the template looks like. Okay, so one thing to notice here, this is slightly different than the Linux example I showed you before. This is actually an ARM template. Because the Azure Vim Image Builder is a first-party resource provider on Azure, we can nest it inside an ARM template. And that means you get all the goodness of ARM templates. You can pass in parameters, you can use variables, and do some string manipulation. So here what I'm passing in, I'm passing a template name, API version location, and an MSI token. So here you can see the Image Builder resource, virtual machine images. And what you'll notice here is that I've got this property called identity. And Image Builder is expecting a user-assigned identity there. Then what's going to happen, we're going to take a source Windows Server 2019. We're going to run some customizations. So first of all, I'm going to get Image Builder to go and create some directories. And then I'm also going to get it to open an outbound port. Then what I'm going to get Image Builder to do is go and download Python 3.7. I want to install Python 3.7 launcher into my Windows image because I believe that my corporate downstream departments all need this and I want them to standardize on that particular executable. Then lastly, I'm actually going to do a run on that, so I'm going to install Python. And then lastly, just to prove that we can, I'm going to do a restart on that image during the configuration as well. We're then going to distribute it to, and again, we're going to distribute to a shared image gallery. And then if you look right down towards the end here, you can see I'm actually going to be putting it into the Windows 2019 golden images image definition. And I've got some regions I'm going to replicate to, East US and West US. So then, simply to actually kick off the build, I'm just going to kick off a new deployment, reference that template, and what that will do is that will submit the template to the Image Builder service, and then you will get this image template resource back. Then you just go and invoke build, and it will go and start running. Now you can actually check on what the status is of the image build. I already went ahead and built the image because it takes a while, and I thought waiting a few minutes for it to build is not going to be a great use of time. I can actually check the status when the Image Builder is running, and this is one that I actually did yesterday, and it tells me what the provisioning state is. The build succeeded, so this has already gone ahead and actually run. So we've gone and created the image. Now let me show you what it actually did in the background. If I go to the Azure portal and I go to my shared image gallery and I go to my image definition here, Win 2019 golden images, I go to image versions, and you can see an image version. This is what the Image Builder inserted yesterday, built from that template. If I go into there and I click on Update Replication, I can see that it's been replicated to East and West US. What I can do is I can actually modify these properties. I can increase the number of replicas. I can increase the number of target regions, I can reduce it. One thing, this wasn't actually possible until a couple of days ago. If you actually want to be able to do this, there's a feature flag that you have to enable, and it's in my documentation. You'll see it there tonight. However, I think at the end of the month, you won't need a feature flag to actually modify the image properties anymore. So what I went ahead and did, I actually went and created a VM straight from that image, and it's quite simple to do. You just click on Create VM there, and you see the VM properties. And let's go and have a look at what happened there. So here's a VM I created from my golden image, and the first thing you can see is that I actually have the Python launcher there. Okay, so the image builder went and baked it in for me, and that happened to work okay. You can also see here, not very well, but a text file was inserted when Image Builder did a restart, and then lastly, it's opened outbound port 9001. So again, this is a bit of a contrived example, but just to give you an idea of what you could do. Now, what actually happens is when the image builder actually runs, or you submit run on it, it uses this staging resource group within your subscription, and you can see it. There's a naming format. It'll always start with IT underscore. It will have your resource group name in it and the template name. When it actually runs, it will create a VM and some other resources inside that staging resource group, and it basically launches a VM, does its customizations, and then it deletes it right at the end once it's created the image. So let's go back to the slide deck. Wrong one. Okay, so what you just saw was me take some configuration as code. You saw Image Builder reach out to the storage account using a user identity and then inject it into a shared image gallery. Next demo. I now want to make this image available to all my downstream departments. So I've made the corporate policy and said, right, everybody always builds from this golden image. And so the application development team want to build a web app on top of it. So again, they've got some configuration. This time their configuration and their scripts are actually sitting on GitHub. And so Image Builder is going to pull them down, install an IIS web server, and create a website. And then what I actually want to do is I want it to then go and distribute into a new shared image gallery definition. This one is called Win 2019 Web Images. So let's go back to the laptop. Okay. So again, I'm just going to pull out the salient points here. So we had to create a new shared image gallery definition. That's probably one of the only major sort of change to the infrastructure we did. And then let's actually have a look at the template. Let's see what I did in the background. So a couple of things. You'll notice the properties are slightly different this time. The build timeout, I think, is a bit higher. I've also told Image Builder that I want it to use a certain VM SKU. By default, if you don't specify any VM size, Image Builder, I think it uses a D1 V2. It uses quite a small VM. However, if your customizations are quite CPU intensive, you can up the compute power. Also, if you're building custom images that are dependent on certain hardware being available, such as GPU SKUs, then you can specify a GPU SKU hardware underneath it. What you'll notice here is that the source is different this time. We're using shared image version, and this is where you specify the shared image gallery version. And what you can see is I'm saying, right, I want to take the base image, golden image that I just created from the 2019 golden images image definition. Here's the version, and I want you to use that as the base image, as the source. And then I'm doing some customizations. So what I've done is, me being Mr. Creative, I've gone and created a web page. And what you'll see is here, it's just some HTML, nothing particularly exciting. And it's going to put that into the image, into this directory here. And then what I'm going to do is I'm going to build an IS web server. So again, I've got some PowerShell that I'm running. I'm installing IS on here. I'm setting up the site, and then I'm opening up a firewall port as well, and then cleaning up after myself. So what I did was I'd already gone ahead and submitted that. That's already been has already been built. So let's have a look and see what the outcome of that was. So let's go to the next one. So I've created a VM, and then what you can see is here, IS is already installed, up and running. But I think what we really want to know, does the actual website, is it reachable? Did the configuration work? We can check that out. Let's go back to the jump box. And let's see if the web config works. Okay, and that's actually a page coming from that web server. So Image Builder applied the config to that golden image. So what we've done is we've taken the golden base image, we've built on top of that, we've installed IS, I've put on the most interesting web page, and Image Builder's gone and baked it all into the image. I've created a VM, and now you've gone and built your application on top of that golden image. We can also have a look and double check to make sure that I'm not conning you. If we actually go back to this image, you can also see that the Python launcher is installed as well, and you can see it there. So that's all up and running. So let's go back to the slide deck. Now, it's all very well you can go and run your scripts, but how do you actually know they've run successfully? When Image Builder actually runs through your configuration, it basically relies on your scripts that they're good and that they're returning 0 exit codes. If you run a script and it returns a non-zero exit code, Image Builder will fail the customization, it will fail the build, and it will tell you, it will say, this has failed in the customize phase, here's where the error log is, good luck. Now, what can you do about that? How can you actually know whether what you're doing is actually been installed correctly? The script may have run, but are you actually getting the features you want? So one thing here, what you could do, you can actually integrate unit tests. So I got this idea from some of the customers who I've been working with, and what they were doing was they're building Windows virtual desktop images. So they install FSLogix, that needs a restart, and then they want to run unit tests. So they want to run a unit test to say, okay, well, did the install go correctly? Is it the right version? Is the service running? i.e. validating that the install is what they expect. And then to here, they're just pushing out straight out to a shared image gallery, and that's pretty much it. Who here's heard of Pester? Okay, a few of you. So essentially, Pester is a framework which will allow you to run unit tests. I'd never touched Pester in my life until about 3 weeks ago, and I actually got some very simple unit testing up and running. And it didn't take long to actually learn it at all. So let's go and have a look. First of all, let's go through the image template that I used. So the template I used is I'm going to use a PowerShell type. I'm going to just be taking a marketplace image. Oh, sorry. And then what I'm doing is here, I'm getting Image Builder to install FSLogix. If I just follow this, you can see that it's a very simple script. It's nothing special. We're just downloading straight from this link here, extracting and installing. Nothing really magical about that. Sorry, wrong one. Sorry, wrong screen. Then the next thing is FSLogix actually requires a restart. So we're doing a Windows restart here. And then lastly, what I'm going to do is I'm going to actually ask Image Builder to then go and do some unit testing. This actually looks a lot worse than it is. So all this code is available on my GitHub repo. Now, basically what it's doing is initially it's just going to download the Pester configurations. Then it's going to install Pester, and then right at the end, it'll kick off the tests where we run Pester. And basically, if there's an error that's returned from Pester when the script or the test run, I'm going to return exit code 11. Because that's a non-zero exit code, if there's an error in the test, Image Builder will fail the customization. So let's actually have a look at in a bit more detail what's going on. So the install for FSLogix we looked at. This here is the script that we're using for Pester, which you just saw. Obviously, it's a bit more colorful now. And then let's have a quick look at the Pester tests. Basically, with Pester, you describe the test you want to do. And what I'm doing is here, I'm saying, look, I'm installing FSLogix. I want you to get the service status. And then if the service is equal to, if the service is running, then I want it to be compared to, it should be running. I've deliberately misspelt this because I want the test to fail. Then here, I want to check the version of FSLogix, and I'm saying that the version should be this. If the version changes without me knowing, I want the image build to fail. So what I went ahead and did, I've already gone and created it. The image build never actually succeeded because basically the install does work. However, the status is running and it's not running. Now, what does that actually look like? It looks like a lot of text. So let's take this out. And what we have is here, this is actually the log that Image Builder produces when it's actually running. And it's quite verbose, as you can tell. And this is actually the part where I'm installing Pester. And because I'm doing write host, it writes it all into the log. The log is actually located in the staging source, in the staging resource group when you run Image Builder. And here you can see Pester being installed, and then what you can actually see is that it's actually gone and failed, and it's come back and it said communicator ended with 11. So Image Builder picks that up because in Image Builder's terms, the customization has failed. It's run Pester, the Pester script has run, it hasn't returned 0, it's returned 11, and Image Builder has just gone and cancelled the build. So, and you can also see in here, you can actually see the Pester output as well on this line here. Again, this is a very verbose log, but it does some validation testing for you. Okay, so what we saw there, we saw me install FSLogix, you saw me do a Windows restart, and then you saw the unit tests run. They were returning these non-zero exit codes, and that was pretty easy to implement. I mean, you've already probably got the scripts. If you just want to add unit testing, it didn't take me long at all to actually learn Pester and implement that. So automation, you could literally take my scripts that I've got on my quick starts, you could copy and paste them, and you could be up and running in about 10 minutes or so and have an image creation system building your image, and you could have shared image gallery. But if you're going to do this on a bigger scale where you want to build images quite a few times a month or a week, you're going to want to automate that. So what options do you have? Image Builder actually supports Azure Devops. So we have an Azure Devops task, and what that does is that actually simplifies what you've seen today. So you saw that when we want to create an image, we have to submit it to the Image Builder service, then we get an acknowledgement back and an image template artifact, and then we invoke run on it to build it. The actual DevOps task abstracts that completely. Now, the way the DevOps task is set up, you can basically get the task to drop in your build artifacts directly into the image, and I'm going to show you that in a second. So I've got a demo where we're going to use DevOps to pick up your build artifacts in your repo. Image Builder is going to drop them in there, and then it's going to create an image. So let's go. So here's my Azure DevOps task. We're not going to go through step by step on how to create an Azure Devops project. This is all documented online, and I've also got an awful video with me narrating that goes through the steps for you. So let's have a look at the files. So me being Mr. Creative, you'll notice the trend. I've got this HTML file, and it's just going to create a basic page similar to what you saw. I've got this web config again. It keeps making a comeback, and it's going to install IIS. Okay, so nothing really amazingly special there. So then what I do is after that, I create a release pipeline. And let's edit the release pipeline. And what I do is I set up some artifacts, and I link that to my, my repository there. So this is just linking to that repository where those files are. And you'll see why that becomes important in a second. Then what I do is I create an image build stage. So let's jump into the stage. And if I didn't have the task already, it's quite simple to add it. You can just go to Add, and then you do search for Azure VM Image Builder, and you'll see it down here. It's in the marketplace. And again, there's all the instructions in the repos on how to add that. Now, I've obviously already gone ahead and set this up. So let's have a look. Let's make that a bit better for you. And here's the task, properties. And you can see here, we've got the source. So I can, again, tell Image Builder what I want to use. If you're already taking, if you've already got a golden image you want to use, you can just select the shared image gallery or managed image. You can also pass in Devops variables into it. So here, for the version ID, you could run some code before to go and get the latest shared image gallery version. And then in the customize phase, obviously we've got PowerShell and we've got Shell. That's all we support. Now the build path. If we now look in the build path, you'll see I've got the linked artifacts available to me. And if I drill down, you can see the web app. So what the image builder task is going to do is going to take all these files that are in the repository and then drop them into the image for me. Lastly, I can then just run some inline customization. So what this is actually going to do, it's going to run this PowerShell script that configures the web server, and it's then going to create obviously the website as well as configure the server. Then lastly, what it will do, it will then distribute to the Azure Shared Image Gallery, and we've just putting it into WestUS. Now I've already gone ahead and run that, so let's have a look at some history. Oh no, wrong one. Where have we gone? I've lost myself. I can't see it. Oh yeah, view releases is out of sight. Yeah, let's leave that. And then here, you can see I've been testing with it. If I jump into it, you can see what some of the output looks like. And here's the image builder task that's running. So what it's basically done is in the background, it's gone and created a template for you. It's gone and submitted it to the service, and then it starts running a build on that. And then if it's successful, it will delete the template and clean up after itself. It probably takes, to actually set up that DevOps task, I would say it probably takes about 15 minutes or so to create that. If you look at my video, hopefully if I haven't misled you, you might even do it quicker than that. But again, it's very useful to get this set up. Now, whilst we're here, we're using DevOps. You could also use this with other automated CI/CD pipelines. Because Image Builder is a first-party Azure service, you can just directly hit the API, so you could use it with other pipelines as well. That wouldn't be a problem. So really what we saw there, we saw Image Builder taking configuration as code. It's also taking your application code and then building that and putting it straight into an image. As a developer, developers can actually test end-to-end and drop their applications directly into corporate images and test them. Now, before we go on, we've got just a couple of minutes. There's one other demo that I'd like to show you. So I haven't actually got a slide for that because I thought we may run out of time. Now, what I showed you before was that when Image Builder runs, you can see that it basically dumps out everything to this customization log. So you can see there what the errors are. Now, also, if you wanted to find out maybe if your tester failed, you'd have to maybe go and look in the log and try and understand it. And one of the ideas that some of my customers have been playing around with is sending out telemetry from Image Builder. So how could you actually do that? And I was looking for a way to do it. And this is, again, just one method. And if you keep your eye on the quick starts, you will see the documentation appear for how this happens. What I did was I used Logic Apps. So Logic Apps allows you to basically build a small application, and I'm not going to go into too detail, but it's really just to give you an idea of how you could do this. It basically allows me to create a small front-end API. So I can pass in to this URL, I can pass it some properties. And what that will allow you to do is instrument your code. So all you need to do is inside your code is basically just do HTTP posts, and you can pass in anything you want. So if you wanted to actually instrument what Image Builder is doing, and maybe you don't want to wait till Image Builder actually finishes failing the build, you can actually see what's happening as Image Builder is doing your customization. So it's pretty useful. Some of the code, what that looks like, let me just show you. Again, I'm not going to go into too much detail, but it's just to give you an idea of how you could achieve this. Where are we? Demo 4. Wrong one. Demo 5. What I basically did was created a function, and it then basically just does an invoke web request. So I'm sending job ID, step ID, and then I'm basically then sending it to the endpoint. And what happens is, inside that trigger, it receives this, and then it puts it into a storage table. And then what you can do is, you can see here, let's get rid of that. Sorry, I'm having screen trouble. So you can see here that I've got some telemetry coming from when Image Builder was actually running through the IIS server build. So here you could see it was doing it started the IIS configuration, it's running through, it started the Pester Tests, and then I actually messed up my Pester Tests. There was a problem on my script, and it blew out, and it said 404 not found. I put in some additional logic, and then the tester pests then started rerunning. But again, this is just to give you some idea. You can then also actually extend the logic apps, and then you can pass in the job ID. So if I go back here, if I go back to I've got a different logic app, and this is very slightly different. So what I'm going to do is, all I do is I pass in a job ID property, and it then goes and retrieves those entities from the table. So very simple. And then it goes and sends me an email. And the entities that you just store in the Azure table storage, it's gone and sent me an email, and it tells me Azure Image Builder hates me. So again, it's just to give you an idea of how you could maybe make life easier for yourself. Again, I don't use Logic apps. It's probably the first time or second time I've ever used it. This probably took me about a day because I had to design it out, what I wanted to do, and then how to instrument it. But things like here, like noticing when your script fails, it's a lot easier just to see it there and identify you've got a problem and then start working on it. So that was just one thing I wanted to share. Okay, so let's just summarize up. So you saw how we can create an image creation and management system. You saw me create a golden image. You saw me then put an application on top of that. Everything that we've done can be done in Linux as well. So there's not really any difference. It's the same principles underneath it. You saw me build a Win10 image and do some unit testing. And then lastly, you saw the integration with Devops. So what about the roadmap? Image Builder's in public preview. Where are we going next? A couple of things we need to achieve. Priority number one is supporting connections to existing VNets. What I told you was that when Image Builder runs, it actually creates a VM and it puts it in this staging resource group. Customers would like the ability to actually have that staging VM put on their existing VNets, and that would allow them to maybe connect to existing resources such as Chef servers or Puppet servers or what other configuration tools they have. So we're certainly working on that. I'm hoping we'll get that done before the end of this year. Also, some UI and CLI and PowerShell support. The CLI and PowerShell support that you saw me use, that was just using very generic commands, PowerShell commands. Simplified security. To make Image Builder work, you have to grant the SPN rights on top of to the resource group where the shared image gallery resides, and then you also have to, if you're using managed identities, you have to then add them. So essentially you're doing two sets of security there. We want to simplify that right down. Additional admin functions, such as being able to cancel the build, improve troubleshooting. I've asked the developers to see how they can actually get the errors out of the customization log and surface them back to you directly. That's definitely want to see if we can get that done. And then increased region support. So GA. GA will be early next year. We're in the position now where we're ready to onboard a small handful of customers who want to run production image builds. And where we can provide them some support. So if that's of interest to you, please reach out to me. So to get started, these are all the links for you to get started. aka.ms, AZVim Image Builder. All the demos are there, all the instructions. And just make sure everybody's taking a picture. And then lastly, thank you very much for everybody for listening. I appreciate it. It's Friday afternoon and everybody wants to get home. I also want to say thank you for the dev team. I'm the guy who just comes and talks to you about it, but there's an army full of developers behind it, Sumit, Paul, Amrita, and Rempeng and Feu. We've also had some great customers providing testing and feedback. We listen to customers very much. We also have a private MS Teams channel with, I think, just under 400 internal and external customers. We listen to the feedback. The developers are on there. If you're interested in joining that, please just reach out to me. Happy to add you. And also, just like one last call out, ideas for demos. Jean-Paul van Ravensburg and Jim Mole were really helpful with some of these demo ideas. As you can tell with some of my quick start templates, I'm not the most creative person in the world. So thank you very much. Please don't forget to fill out the evaluations and have a safe trip back. Thank you very much.